Hello everyone, this is me Rohit here, and today we are going to see about binary representation. The first question would be like, what is binary representation? Binary representation is nothing but we are going to represent numbers into ones and zeros, where that ones and zeros are nothing but binary. So we got to know what is binary representation and what is the main purpose of it, or why binary representation. So we all interact or we use computers, smartphones, iPad, tablets, and all the electronic stuffs. So for that devices actually finds humans language as something more complicated. So it converts that complicated language into a simpler ones. That's nothing but binary representation. So we got to know what is the purpose of this binary representation. Let's get into the video. Now we are going to see how to convert decimal to binary, hexadecimal to binary, and octal to binary. So let us take an example for decimal to binary. Let me take a decimal value 88 to the base 10. We know that decimal has a base of 10 and we have to convert into a binary which has the base 2. So let us divide the 88 by 2. So I use the LCM division method. So put 88 over here and divide it by 2. So we have quotient as 44 and we don't have any remainder, so put 0 beside it. And again divide the 44 by 2 and we have quotient as 22 and we don't have remainder again. And again divide 22 by 2, we have 11 and then we don't have remainder again. And again divided by 2, so 2 5s are 10. So put 5 as we have the 5 as the quotient, so put 5 over here and we do have a remainder which is 1, so place it beside it. So again divide the 5 by 2, we have 2 2s are 4 and again we have a remainder and place 1 beside it. And again divide 2 by 2, so we get 1 and then put 0 beside it because we don't have any remainder again. So again divide the 1 divided by 2 is we have quotient as 0 and put remainder as 1. So now we have what we have to do right now is like represent the reminders from bottom to top this way, so that we get the the binary value of the decimal 88. So the the binary value of 88 is nothing but 10110000 to the base 2. This is the binary value of decimal 88. Now we are going to see another example how to convert a decimal value to a binary value. But now we have a decimal point over here. So let us see how to do it. So we have to multiply this number by 2. So 0.527 multiplied by 2, we get the product as 1.054. And what we have to do is we should not consider the number which is before the decimal point. That is 1, we have 1 over here. We should not consider that 1 here, but we have to consider 0.054 and we have to multiply that number again by 2. So what we have done in the next step is 0.054 multiplied by 2, we get 0.108 as the product. And again we don't have any value before the decimal point, so let us take the whole number and then multiply it by 2. So 0.108 multiplied by 2, we get the product as 0.216. So that again we don't have any value before the decimal point, so then we have to again multiply it by 2, and again we get the product as 0.452. So it's not necessary that we have to continue till we don't have any numbers after the decimal point. If we had three digits after the decimal point, so we stopped it after 4 digits. It's your wish to stop at any point, but I would consider this is enough to that, so we get the final answer. So now what we have to do is we should only consider the values that is before the decimal point, and we have to write it in the order from top to bottom. So our decimal value for 0.527 would be 0.1000 to the base 2. We have to add a decimal point because this is a decimal number. A decimal number, but which has a decimal point. So we have to add a 0.1000, so that this is the final binary value for the decimal number 0.527.